Hello everyone, I'm pleased to be here today to talk to you about using Barkhausen-Noise technique, measuring residual set of sheet medium carbon steel in strength hardening. Uh, First, I'm pleased to be here. I'm going to talk about research content of the introduction and background research methodology, result and discussion, and the conclusion. Okay, so little state is that pieces in the material even when the material is not subject to external force. Principle of destructive testing, such as the micro hardness, tensile test, and metallurgy is the most common method to use to measure the hardness and the resistance set of the various materials. However, these tests are costly. They have uh, they have to in the lab and unsuitable for use in the field. Therefore, the non-destructive testing have come into fashion. So, Barkhausen noise technique is one of the NDT or the non-destructive testing for everything physical properties of the ferromagnetic materials. So magnetic field line make the closed loop and run from north to south outside the magnet. Random domain isn't net magnetic field. When many of domains line up, you get a net magnetic field. The Barkhausen noise is based on the discontinuous movement of the magnetic domain walls in ferromagnetic materials due to being simulated by changing external electromagnetic fields. Then resulting the noise within the material that is Barkhausen noise. Uh, the, the signal features of the BHN signal are influenced by the difference of material property in the hardness and external force. So BHN signals characteristic under external force profiles. The amplitude of BHN signal received from the compression have a smaller amplitude than tension force. This research aimed to propose a suitable method for measuring the residual set of AISI 105 sheet steel with ASTM standard. The BHN system were used to measure and calibrate with XRD technique or X-ray diffraction technique. Okay. Then I forgot on this methodology. This is the diagram of system. I will start with the waveform generator. Waveform generator was used for generating sine wave signal at a low frequency of about 5 Hz. This waveform was power used the power amplifier for gaining the current up to 1 amp to simulate the exciting coil to excite the electromagnetic field into the materials. Then BHN signal caused by magnetization was measured using the pickup coil. The signal amplifier and a low pass filter were used to improve the BHN signal obtained from the probe. The current and temperature sensor were used to monitor the exciting current and working temperature of the circuit, and also give feedback to the processing unit or sensing signals were received via a data acquisition or DAQ interface with the personal tablet. Data and signal processing were performed by LabVIEW programming. So the material used to make the work pass is AISI 105 material is cut via wildcard method according to the ASTM E8 standard. The workpipe is a sheet steel had a 3 millimeter of thickness. The workpipe is permanently deformed by tensile test and at a different elongation to perform the tensile test beyond the yield point, but not exceeding the ultimate point. That is tensile test performed during the strain hardening to the achieve different levels of the residual state. Okay, then test by measuring the hardness before pulling and after pulling workpiece. The range of hardness measurement is in the gate length obtained from the calculation. Workpipe increases its hardness due to the state. It's also resulted in the residual state by the sheet workpiece have elongation of 4%, 5%, and 8%. Then tensile test workpiece are taken to measure residual state by the XRD technique as a benchmark for the calibration signal value obtained the BHN system. Okay, next I focus on the signal processing. Okay, at first the BHN feature and residual set were very as the previously mentioned in this research. Patients interest the result obtained from the peak-to-peak amplitude feature is a measure of the difference between the maximum width in the negative peak and positive peak of amplitude. This feature is therefore the most commonly used for a correlation. The BHN system perform a series of experiments and concluded that the feature of 5 Hz coil excitation frequency and 1 amp coil excitation current would be the best case to bring. Okay. This is due to measure the signal since is the most linear trend feature of the graph. Therefore, the regression equation is applied, which has been converted to residual set for a sheet workpiece. By the distribution of data in the sheet workpiece, 5% of elongation is quite a bit more than the others. Because of the pooling control is quite difficult. Therefore, it affects the measurement accuracy in that range. After obtaining a prediction equation, therefore the BHN system was used to measure the resource set again. This is compared with the resource set obtained by the XRD technique to test the performance of BHN system. Therefore, the average error in the BHN system is 3.98%. All this system had a measurement accuracy of the 96.02% on average. So,
Sir, you have 2 minutes to conclude, please.
the average resource set values measured by BHN system were then compared with the resource set value by XRD technique. It's noted that the highest error was found in the 5% elongation. As this may be due to the fact that using the linear multiple calculate, or maybe the pooling control is quite difficult. However, the measurement accuracy of the proposed system is 96.02% on average. Therefore, it can be similar that non-destructive residual set tester based on BHN technique can be used to measure residual set accurately. To sum up the The BHN system aims to increasing the convenience and the speed of the laser set measurement, and also reducing inspection costs. The conclusion of this work are follow. The conclusion of work is follow the exciting frequency and the appropriate exciting current used to measure laser set are 5 Hz and 1 amp. The accuracy of BHN system is 96.02% on average. When the measuring a laser set of the BHN system measuring instrument compared to the XRD technique, which is enough for steel industry to use as an inspection method for the quality control. So, thank you for your attention.
Thank you very much, sir, for your presentation. And I'm going to ask the audience if any question. Thank you, sir.